Hello everyone, good morning. So this is our second video on Delcam Power Mill. So with our first video, we discussed how to import the model, how to measure the model, how to define the work plane, how to create a block, how to create a various tools. With this new video, we are going to discuss how to create a toolpath, how to simulate the toolpath or checking its machining view. I hope my first video was a knowledge gaining to you and I assured the same thing in this second video. So let's start. So here I open my power mill. So if this is the model and I want to create the toolpath. So before to create the toolpath, again we have to create all that basic thing. Like now model is already there. So we have to create the job zero. We have to create the work plane. We have to create the tools. So now to create the work plane, I will use the option work plane, create work plane, create an oriented work plane, create work plane at the points. So I click here work plane at the point. But again this work plane get created, but it is not an active work plane. To active it, we have to just click here in the work plane, click the plus button. In that it's showing work plane number 1. Right click over there and press the button active. So now work plane get activated here. So next step should be you have to now create the block. To create the block, you have to click here. It is called as a block option. Then with that, normally we choose box option and you have to press the button calculate here. So now you will find the material get created here. So press the accept here, your material also get created. Now let's start the process with the one of the cutter that called as a 52R6. So to create that cutters, you have to right click here on the tool, then create tool, then choose the option tips radius. Tips radius means insert cutter. Here you have to define the diameter. Suppose the diameter it is of 52 mm is the diameter. Then with the corner radius with the 6, it means the insert with this cutter will be of 6 mm. Then length we will discuss later. Here you have to label it 52R6. Then you can define number of insert. It is 4. So here tool get created, say close here. Now we created the tool. So next steps will be we have to apply speed feed to this tool. To add speed feed, we have to click beside the block symbol. You will find the label speed feed. So click here speed feed. Now with this form, there are two methods to add the speed feed. This side is called as a, if you know the cutting parameter. If I am the working fellow, I am working since last so many years, so I know about at what speed feed that cutter can work well. But if your material is new, very hard material, tool is new, you change your tool supplier, so that time they will suggest you some cutting parameter. So if I said ki I know about the cutting condition, I can directly write here. Suppose I consider 52 diameter cutter will work at that RPM of 1000, RPM of thousands. So here I will make it 1000. Then this cutting feed rate, it means table. Cutting feed matlab table feed. It is cutting feed means table feed. It is mm per minutes. Suppose I put right now, I put that cutting feed as 1200 mm per minute. The unit is very important. That feed is mm per minute. Then plunge feed. Once I click here, I have defined the cutting speed of 1200, and if you click it here, the plunging feed means Z entry feed will be automatically updated over there. I just click here and you will find that answer will be 120. It means that it is in the ratio of the cutting feed. So this table feed and this is plunge feed. Table feed means XY feed. Plunge feed means Z feed. Z means when the tool is entering in the material, that time it should be go with very low speed, and standard ratio between cutting feed and plunge feed is 10%. So that's why answer is 120. If you want to change, then you can change accordingly. So the next one is called as a scheme feed rate. Scheme feed, if you keep the cursor hold over here, just keep the cursor hold nearby, it will show you the meaning. Not showing right now. So it is called as a scheme feed rate, and scheme feed rate means feed rate used when not removing the material, means it is a rapid. Rapid is depend upon your machine. Sometimes if your machine is a new one, very new one, so its rapid is very high. But if it is your old machine, so that rapid may slow. So if my machine with the rapid of 10,000 mm per minute, so that time I will use 5,000. But if today's machine is up to 40,000 mm per minute, So that time also you have to use half of that value. Suppose my machine with the 20,000 mm per minute is the rapid, I will prefer 10,000 only. So this is called as a, if you know your cutting condition right here. But sometime if with the new material and new tool, it is always suggested you have to take the help of the tool manufacturer while deciding the cutting parameter. So tool manufacturer always supply you two things. One is called as a surface cutting speed and feed per teeth. Surface cutting speed is called as a VC, cutting speed of that material, and it is given on that insert box. Suppose it is suggested by tool manufacturer is 180 meter per minute. If you write 180 meter per minute and enter, you will find your RPM is getting updated here. Means once you define the cutting speed, RPM will be automatically set. Then again, feed per teeth. Suppose I write the feed per teeth is 0.4. Enter, you will find your cutting feed is getting set. If I change it, I make it 0.3. Sorry. If I make it 0.3, enter, you will find it's getting updated. So if you write these two data, surface speed and table feed per teeth, automatically spindle speed and cutting speed vary. So two option is there, it's up to you which to be used. Then axial depth of cut, radial depth of cut, no need to write it here. We will write these two value in a toolpath creation. So here with this topic we discuss how to define speed feed. With that, spindle RPM, cutting feed, plunging feed and skim feed rate. Or you can define surface speed and feed per teeth accordingly. Rest of the parameter will calculate by software. So press the close over here. So it means speed feed get applied. So now the next topic will be how to create toolpath. When we say we are cutting the job, so first process is of roughing. So in the roughing, there is a different method. In the finishing, there is a different method that called as a strategy. So to create a toolpath, you have to click here in the Explorer. Just click here on the option toolpath. Right click over there. Click the button create toolpath. Now you will find this option will be there. So with that, there are so many options: 3D area clearance, curve machining, feature machining. For the roughing, you have to choose the option 3D area clearance. With that, you have to use the sub option model area clearance always. So 3D area clearance, then it is model area clearance. It is a strategy. Press the OK button. If you press the OK button, one form will appear on your screen. Is it? So now this form is showing here. With this form, this left side is called as again Explorer, which is available here. And if you choose the option accordingly, the right side of your screen is getting changed. It means if you click the block option, the block tool will be open. If you click the tool option will be open. If you click here model area, it will be changed. So there are two options: either you define your block tool outside, or even you can define through this form also. So we have already defined outside, so we will not change over here. So once you open this, you have to click here in a model area clearance tab. If you click here, you have to fill up some parameter here, and that parameter is firstly it asking for the cutting direction. Cutting direction, it is defined with the climb, conventional, any. So always use the climb. Climb means clockwise spindle rotation. So climb means M03 like. Then it asks for the next value. It is called tolerance. Tolerance means level of accuracy. As we said, this is a roughing process. It means some of the material you have to keep on the material. During the roughing, accuracy is not matter, because here only a heavy cut, so roughing will be there. So at what accuracy you want roughing, that you have to define. But 0.1 is the suggested one. 0.1 is the suggested one, so we'll write 0.1. It was already defaultly provided over there. If you want to reduce it. Then what is thickness? Thickness means stock for finishing. As we are saying that this is a roughing process, it means some of the material you have to keep pending for the finishing tool. So that called as a thickness. I say 0.4 should be the material remain after machining of this tool, and this material will be removed by the finishing tool. Then let's come to the next point, that called as a step 4. Step 4 means if this cutter is machining along this direction, then it will shift, again it will back, again it shift. That shift is called as a step 4, or it is called as a new working engagement. So it is always in a ratio, and it is suggested by the tool manufacturer what should be the cutter engagement. So that normally prefer 50%, 60% to 75% of the cutter diameter. So with my present cutter, it is of 52 mm diameter. I will prefer it 50%. It means 26 mm. 26 to 30 mm is the most preferred value for the step 4. Then step down means depth of cut. Your cutter will move it will take one cut, then it will come down again, then it will come down again, next cut, come down again. That call as a step down, or step down means depth of cut. So again, depth of cut is dependent upon what is the size of the cutter, what is the material, what is the O-rank, and accordingly tool manufacturer will suggest you this value. So right now I consider it as a 0.5 mm. So for every cut it will remove 0.5 metal, again next cut 0.5 metal, that call as a step down. Like that, these are the parameter you have to keep adding according to your requirements. But with my first toolpath, I only change four things. One is the tolerance, thickness, step 4 and step down. Tolerance normally 0.1, thickness vary from 0.2, 0.3 to 1 mm, step 4 from 50% to 75%, step down again defined by the tool manufacturer. Once you write these things, you have to press one button that called as a calculate. If you press the button calculate, now you will find a machining process is getting the procedure. So you have to wait for, now you will find this cutting process get developed here. Just press the close button over here. Now it's showing this green indication is a cutting action, then this red is a leap, pink is a link of one cutting action to another cutting action. So this call as a tool path, this call as a tool path. So here it was the model, then yellow was the here material, and this green is the cutting get developed here. So it is the tool path already get created. Now if you want to check how that material going to be removed, that call as a simulation. To check the simulation, you have to create here in the toolpath, just click the plus button, click that toolpath number 1 which we created right now. So right click, and here it is option is that is called as a simulation from start. So press over here. Now click this red button, it's called as a simulation on, view mill on. So click it, wait for some minute, this bar will be open. So now simulation bar get open, then you have to select shade of machining. So normally prefer is a rainbow shade. So once you keep the rainbow shade, then but this green line and this pink line is showing, you can remove it just by simply right click on that toolpath number 1 and remove the activation. So it will not show now. So we have clicked this button that is called a view me on. We have selected the shade that is rainbow. Then you have to select which toolpath it is. So on the left side you will find entity written over there. In that entity is a list of toolpath will be there. Right now I have just created one, so in the list there is only one toolpath. So I will select that toolpath. Again, once you select the toolpath, tool of that toolpath is already selected. So simply you have to press the button apply here. So switch on the simulation, select the shade, select the toolpath and press the play button. Now you will find that material cutting action showing over here. In the same way, in what way it is showing here, same will be on the machining. So after this tool running or cutting the material, what will the shape of that job will be shown here. So watch these things. It will take some time because it is simulation, it will take some time, so you have to watch. So these are the cutting actions. So it getting removed and showing here how much time will be required. So we can skip this process also, but just for understanding, we are creating the first toolpath. So we don't have a machine right now here. So simulation will help us to understand what the shape will be there in the cutting and with this much fast rate. So now the shape is coming to that jobs and according to what the model was present. So this is called as a simulations. So we create the toolpath, then we open a simulation, we select the shades, we select the toolpath and we press the play button. Now you will find it's showing cutting action. It is almost to done. Is it? So every time the cut is getting changed. If you find so new time, this cut is showing how much depth it's going with the every cuts. And these are the cutting actions. It's almost to end here. So this called as machining or simulations. So once it will stop, the final shape will be developed. Is it? So here it is going to stop now. Is it? So this is simulations. Stop. It means by this tool, this shape will be developed. So we create the toolpath and we check it in simulation. Now for the next toolpath, we have to exit it. So it's called, I see yes. So we again back to the work. This screen is called as a machining screen and that was called as a simulation view. So with this toolpath, we learn how to create the toolpath and how to simulate the view. So here we cover up to how to import the model, how to create the work plane, how to apply the block, how to apply the tool, how to apply the speed feed, how to create the toolpath, how to check the simulation. So these are the basics methods of creating the toolpath. With our next video, we'll go for how to go for finishing activity. Right? So looking at the length of the video, we are going to stop this video here and watch our next video. Thank you very much. Have a good day.